When you hear the word blockchain, you probably think of cryptocurrencies like Bitcoin. And for a lot of people, it's still a pretty confusing and technical idea. In this explainer, we're going to clarify what blockchain is and what it's actually for once you look past the world of crypto. So to really understand its value, we have to cut through all the hype and ask a really basic question. After all this time, what specific problems does this technology actually solve? To get started, it's really important to be clear about what blockchain isn't. And first on the list is this. It's not some kind of magic wand you can wave at any problem. And second, despite some really bold predictions over the years, it isn't going to completely revolutionize every single industry overnight. As we'll see, its real-world uses are actually quite specific. And finally, this is maybe the most crucial point to understand. For the vast majority of tasks, a regular, old-fashioned database is just better. It's faster, it's cheaper, and it's more efficient. So that really begs the question, why is this technology even relevant at all? Well, to understand its value, we have to look at what blockchain really is. At its very core, it's a shared system for keeping records. You'll often hear it called a ledger that isn't controlled by any one person or any single company. And this gets to the main difference. Think about a traditional database, like the one your bank uses. There's one owner, the bank, and they control the records. You have to trust them. A blockchain is designed for the exact opposite situation. There's no single owner. Instead, everybody on the network has their own copy of the entire history, and making a change requires the group to agree. It's a system built for situations where the people involved might not fully trust each other. So how does it actually maintain this shared record without a boss? Well, it happens in a few steps. First, new information, let's say a batch of transactions, is bundled together into something called a block. Then that block gets a unique digital fingerprint, which is known as a hash. And finally, and this is the key part, the next block that gets created has to include the hash of the block that came right before it. That's what links them together and creates the chain. This structure is absolutely central to its security, because each block is cryptographically changed to the last one. If anyone tried to go back and alter an old record, it would instantly change that block's hash. That would break the link to the next block, and the next, and so on, causing a ripple effect that everyone on the network would see immediately. In this kind of system, you can't hide tampering. It's designed to be obvious. Okay, I know that can sound a bit abstract, so let's use a simple, real-world example to make it more concrete. Tracking food as it moves through a supply chain. All right, imagine a farm harvests a crate of apples. That information, what was picked, when, and from what field, is gathered into a new block. Now, before that block gets added to the chain, other people on the network, like the distributor or the grocery store, get to check that the data looks correct. Once enough of them agree, the block is locked with its unique hash and added to the permanent chain for everyone to see forever. So if someone wanted to cheat, let's say lie about where those apples came from, they couldn't just change the data on one computer. They would have to rewrite the entire history of the chain on thousands of computers all across the network, all at the exact same moment. On any meaningful scale, that's just not practically possible. So this brings us back to our main question. Given these unique features of being transparent and secure, where does this technology actually provide real value? The clearest use cases are in areas like complex supply chains. Think tracing food to its source during an outbreak, or proving that a diamond isn't from a conflict zone. It's also pretty useful for digital credentials. Imagine a university diploma that an employer could verify instantly without having to make a phone call. And yes, in finance, it can help banks settle huge transactions between each other more efficiently. The common theme here is you have multiple separate groups who all need to rely on the same set of records. It's really important to see, though, that even in these strong examples, the change is often an improvement, not a full-blown revolution. In the world of finance, for instance, blockchain is mostly being used to make existing background processes a bit more reliable, not to tear down and replace the whole system. Now, to really have a complete picture, we also have to look at the limitations, because there are some very significant trade-offs that come with choosing to use a blockchain. When you compare them to a standard, centralized database, blockchain systems are a lot slower. They're also more expensive to operate, they're much more complex to build in the first place, and they're a real challenge to update and maintain over time. These aren't just small things, they are major architectural decisions. And that leads to maybe the biggest challenge of all, something called the Oracle problem. You see, a blockchain is fantastic at proving that data hasn't been changed once it's on the chain, but it has absolutely no way of knowing if that data was true to begin with. If someone enters false information, the blockchain will just permanently and very securely store that false information. Garbage in, garbage out. And this all leads us to the final critical takeaway. The most important question you can ask about any new blockchain idea isn't, can we build this? It's, should we? Do the people involved genuinely need a system without a central authority? Because in so many cases, a simple, normal database would be faster, cheaper, and a much better tool for the job. Answering that question honestly is the real key to separating genuine utility from all the technological hype.